Ayan po, good morning, and I am 𝚆𝚊𝚝𝚎 here to discuss about the problem set. And wait lang po, so we will discuss, we will have a bit of discussion here, sharing screen, and this is our problem here is highlighted. So may I read the content of the problem. 3 people are lined up each other from shortest to tallest. They are shown 5 hats, 3 blues, and 2 red. The people are blindfolded and placed on their heads. The 2 extra hats were kept and the blindfolds were removed. All of them were asked if they knew what hat they were wearing. Starting from the tallest, and the middle person both answered that he knows. How did he know? And what is the hat is he wearing? So yun, this is our main problem. And we might continue as well, proceed with the problem, how to formulate the problem on here. Ito, nag-share pa. Share screen. Ito ba yung record? Okay na, sige na. So here po, mathematics problem. So understand the plan. The first step. The first step we will do, understand the plan. Do you understand all the words used to state in the problem? It's what are the used words? What are you asked to find or shown? So yun, tinatanong kung anong hinahanap. Yung tallest, yung hinahanap kung anong kulay. And can you restate the problem in your own? Parang i-restate mo yung sa sarili mong words. Parang i-broaden mo. Yan. Can you think of a picture or diagram? Mental picture, no? I-calculate mo na agad. Is there enough information to find a solution? So, may sapat ba na informasyon na kailangan para masagot ang part? So, next. So, yun nga sabi dito. Ito, which to look for? Ito dito. How does the middleman know what color hat the tallest individual has? Ito notes. We have 3 key points. Hat analysis. 3 individuals are arranged in height order. They each view 3 blues and 2 hats. Hats are placed haphazardly on their heads of the participants after they've been blindfolded, but there are still 2 additional caps in reserve. No? May dalawang reserba. Yung 3 remarks from tallest and middle person. They both assert that they are aware of their own hat's color. So alam nila. Alam daw nila. So next na gagawin is devise a plan. Devise ka ng plano. Think on how you will solve the problem. Was the similar problem you have solved before? Is it possible to use the solution before? No? Parang yun, devise a plan. Gawa ng plano dito. Is there a theorem you can use? Are there patterns? May pattern ba dyan? Parang problem solving, maging detective ka dito. There are many guide questions that may help you solve the problem. You might also start drawing a diagram, no? Gawa ka ng chart, diagram, trial, error, network, work map, or use a formula and be ingenious. So ito yung ginawa kong formula. So ito, potential arrangement of hat color. Yan. Parang in-arrange ko sila. Ano? Blue, blue, blue. Blue, 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 red. Blue, red, blue. Yan. Potential lang. Possibilities lang po ito. No? Itong arrangement na to. So, nag-assume ako na from the middleman to the tallest, at least, alam na nila. Tapos yun. Alam daw nila. Yan. Tapos gumawa ako ng mga dito, solution ay parang key points ulit na puti, na may potential subtraction opportunities for each individual. And the center person, no? Itong tatlong to magkaka-align on how to devising na plan, kung paano na-formulate itong plano na to. Yan po, sabi dito sa potential subtraction, the tallest person would assume that their own hat's color must be opposite if they notice that the shorter person were wearing two hats of the same color. The tallest person must have a red hat in order to be positive that their hat is blue. If they observe that the two persons in front of them are wearing the same color. The most prominent person, however, cannot assume of the color of their own hat if both wear blue hats. If the tallest individual knows for sure what color their hat is, the data becomes beneficial to the intermediary. It indicates that instead of having the same color hat as the tallest person, the middle person has the opposite color. No? So tapos dito sa opportunities for each individual, the tallest person states that the assortment of the hats they see must be distinct because they are able to view the hats of the middle and shortest people. They couldn't tell the difference in color between two identical pairs of headwear. And the center person said, since the shortest person who is unable to view headwear made no assertions, so the middle person must have inferred the color of their hat from the statement made by the tallest person. So yun, carry out ko na yung plan. So yun, kinary out ko na yung plan. Problem solving strategies, yan, nag-diagram ako, red, blue, 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 red, yan, eliminating possibilities, yun, parang kanina, yun, gamitin mo lahat kung what is be resourceful na. And your work carefully, keep an accurate and neat record of all your attempts. Realize that some of your initial plans will not work and that you may have to devise another plan to modify your existing plan. Okay? So, yun. Balik na tayo dito. Yun. Ito na. At the final analysis, the tallest individual uses the process of elimination determine which hat. So, nag-eliminate siya. So, therefore, inisip niya ako yung tallest, red. So, therefore, may apat na lang na red. What I mean, ilan ba yung kan? Yun. Line up, yun. 5 hats. 3 blues and 2 red. So, sasabihin na natin yung dalawa middle at saka tall. Yun, nag-assumption siya. Nag-eliminate siya. Kung si middle at ako na tallest yung red. So, therefore, tatlo yung blue. Yan. There are 2 red hats and 3 blue hats available. One has to exclude the discard the other opinion in order to determine the color with the tallest person in front. With the tallest person in front of 2 others. Yun. The tallest person, yung middleman. If both have blue hats, which means that there are 3 blue hats total, 2 people. There would be 3 hats left. So yun. So 5 sila, 5 tao. And the option would be 1 blue hat left or 2 red hats. 2 hats left, no? There are just 2 options in these situations. Thus, assurance is not achievable. So mag-assume ka na hindi mo alam ba. Yun. Okay. In the event when the shortest person wears a red hat, yan yung sabi dito sa may con, carry out the plan, realize your initial plan, keep an accurate and neat record of your attempts. Record lahat, yan yung mga assumption. The event the shortest person wears a red hat, 2 red hats, 1 person, and the middle person wears a blue hat, 3 blue hats, 1 person. there will be 3 hats left. 2 red hats and 1 blue hat. Once more, there are just 2 options available. Therefore, the tallest individual cannot be certain. Hindi siya certain kung anong ilan yung hats sa kanya or ano yung kulay, no? Ito yung mga assumption ko pa. Nag-assumption ako. The 3 blue hats would be the only ones remaining. Though, if the middleman and the shortest people were both wearing red hats, 2 red hats, 2 people. So, nag-iisa lang. The tallest individual can therefore be positive that their hat is blue because there are the only 1 possibilities left. No? Kapag yung dalawang hat napunta na sa smallest and middleman. So, therefore, nag-assume si tallest man ng siya yung blue hat. Ayun. And the middleman uses the method of elimination then. Just like as the tallest man. To ascertain the color of their hat by depending on how certain the tallest person of its hue. With the shortest person in front of them wearing 2 red and 3 blue hats. There would be 4 hats left, 2 blue and 2 red. If the shortest individual wore a blue hat, 3 blue hats, 1 person. For 4 hats, there are an infinite number of color combination that can be chosen between the tallest person and the middle person. Making a definitive decision and attainable. Ano? So, ito na yung sinasabi na yan, carry out the plan. At saka last, yan, look back. Mag-look back tayo. Nag-carry out na yung plano, mag-look back na tayo sa ating Once you have found a solution, check the solution. Ensure that the solution is consistent with the box of the problem. Interpret the solution and ask yourself whether the generalizations of the solution that could apply to a problem. So, yun. Ito. So, yun. Ito na yung assumption, finalization. The result would have 4 hats remain, 3 blue and 1 red. If the shortest individual wore a red hat, 2 red hats is to 1 person. For the tallest and middle person in the scenario, there are only 2 more feasible combinations, red blue and blue red. Yan. Nag-assume tayo. Nag-devise a plan. Only one of these 2 combinations can result in certainty, because the tallest person wouldn't be sure of their own hat's color if the middle person wore a blue hat. The center must wear a red hat. Yun, no? So yun. So, sabi dito, because the tallest person wouldn't be sure. So, yun. Kasi dito sinabi sa mga evidences na middleman at shortest man. So, si last man, yung tallest man, nag-a-assume lang siya. So, akala niya blue hat siya. Ay, red hat. So totoo pala, blue hat siya. So, yun. So, that is my report for the problem set. And here is the how to problem solving and reasoning answer ay problem solving. So thank you so much, ma'am. Thank you, classmates. Peace out. Wait lang. Yes. Na-ignorante ako sa stop share. Ayun. Record. Saan yun? Ayun. Recording. Bye-bye.
If 8 workers can finish a job in 6 hours, how many workers will it take to finish the same job in 4 hours? To determine the number of workers needed to finish the job in 4 hours, we can use the concept of the work rate. The work rate is the amount of work done per unit of the time. If 8 workers can finish the job in 6 hours, it means that the work rate of these 8 workers in one job is 1/6 job per hour. To finish the same job in 4 hours, we need to find the work rate required. Let's denote the number of workers needed as X. Since the work rate is inversely proportional to the time taken, we can set up the equation. Number of workers times time taken equals constant. In this case, the constant is the total amount of the work required to complete the job. So we have 8 workers times 6 hours equal X workers times 4. Said a while ago, we will multiply the numbers that are given. So 8 times 6 equals X times 4. 8 times 6 is equal to 48. And X times 4 is 4X. So now, let's divide each side by 4. 48 divided by 4. And 4x divided by 4. 48 divided by 4 is 12. Let's cross out, and let's bring down the x.
Hi! Our lesson for today is about finding the unit digit of the sum. Our problem is the unit digit for the sum of 13 to the 25th power plus 4 to the 81st power plus 5 to the 411th power. To find the unit digit for the sum of it, we should first analyze the patterns of the unit digits for each term. And after analyzing the patterns of it, then simply add them together. So for the 13 to the 25th power, let us first observe the pattern of the unit digits when 13 is raised to different powers. As we can see, the unit digits repeat in a cycle of 4. 3, 9, 7, and 1. So since 25 is divisible by 4, then 4 divided by 25 is equal 6, remainder 1. So our remainder is 1, so look for the 13 to the first power. So as we can see here, the unit digit is 3. So we have here the unit digit for 13 raised to the 25th power is equals to 3. So next, let's consider 4 to the 81st power again. Let's observe the pattern of the unit digits when 4 is raised to different powers. As you observe, the unit digits repeat in a cycle of 2, which is 4 and 6. As we can also see, when 4 is raised into odd power, the unit digit is 4, and when 4 is raised to an even power, the unit digit is 6. Since 81 is an odd number, the unit digit for 4 to the 81st power will be the first unit digit in the cycle, which is 4. So the unit digit for 4 raised to 81st power is equals to 4. And lastly, let's analyze 5 to the 411th power. As we can see, the unit digit for 5 raised to any power is always 5. So basically, the unit digit for 5 raised to the 411th power will be equals to 5. So after finding the unit digit for 13 to the 25th power, 4 to the 81st power, and 5 to the 411th power, let us sum it up together. So 3 plus 4 plus 5 is equals to 12. So the unit digit of 12 is equals to 2. So the unit digit for the sum of 13 to the 25th power plus 4 to the 81st power plus 5 to the 411th power is equals to 2.
An egg vendor broke all the eggs that he was delivering to local store. He could not remember how many eggs there were in all. However, he did remember when he tried to pack them into package of 2, 3, 4, 5, and 6. He had one left over each time. When he packed them into package of 7, he had none left over. what is the smallest number of eggs he could have in the shipment. The situation is, an egg vendor breaks all the eggs meant for delivery. He can't recall the total number of eggs but remembers some divisibility and remainder details when trying to pack them into different size packages. The given is divisibility condition. The eggs leave one left over when packed in the set of 2, 3, 4, 5, and 6. There's no remainder when packed in sets of 7. We must find the smallest number of eggs in the shipment that satisfies this condition. My observations are, there's an unknown quality of eggs. A specific remainder condition exists when dividing the eggs into various packages sizes. The requirement to find the smallest number of the eggs complying with all conditions. Possible deductions. If a number leaves remainder of 1 for divisors 2, 3, 4, 5, and 6, and no remainders for divisors 7, it means the number is 1 greater than a multiple of these divisors. The smallest number that fits this condition could be found by finding the least common multiple of 2, 3, 4, 5, and 6. And then checking the consecutive multiples until finding the numbers that satisfies the divisory of 7 condition. The solution of least common multiple of number 2, 3, 4, 5, 6 is equal to 60. The smallest number divisible by all these numbers. Checking multiple of 60 until finding the number divisible by 7 without a remainder. 2 times 60 is equal to 120. 3 times 60 is equal to 180. 4 times 60 is equal to 240. 5 times 60 is equal to 300. 6 times 60 is equal to 660. 7 times 60 is equal to 420. So, 300 is divisible by 2, 3, 4, 5, and 6 without any remainders. 301 leaves a remainder of 1 if divided by 2, 3, 4, 5, and 6, but is divisible by 7 without any remainder. The smallest number of eggs that the vendor could have had in the shipment satisfying the conditions is 301 eggs.
There are 1,000 lockers in high school with 1,000 students. The first students open all 1,000 lockers. Next, the second students closes lockers 2, 4, 6, 8, 10, and so on up to lockers 1,000. The third student changes the state, opens lockers that are closed, closes lockers that are open. Of lockers 3, 6, 9, 12, 15, and so on, the fourth student changes the state of lockers what will be open at the end. So here's the given. The first student opens all 1,000 lockers. The second student closes every second locker 2, 4, 6, and so on. The third student changes the state of every third locker 3, 6, 9, 12. This pattern continues with each subsequent student. What to find? The number of lockers that remain open at the end of his process. In solution, The number of perfect square up to 1000 is equal to number of lockers that are still available. In looking back, the count of perfect squares up to 1000 represents the number of lockers remaining at the end of students' interaction. To determine the count of open lockers, identify the numbers of perfect square less than or equal to 1000 with 1000 lockers. The largest perfect square less than 1000 is 31, resulting in 31 open lockers at the end. It contains initial state, student action, analysis, open lockers, counting perfect squares. Therefore, at the end, we all has been completed, 31 lockers will be open.
So now, we are going to solve the can-can puzzle. Fill in each square cell in the puzzle with a number between 1 and the size of the grid. For example, this is 4x4 grid. Use the number 1, 2, 3, and 4. Use each number exactly once in row and each column. This is 4x4 square. So, use the number 1, 2, 3, and 4. This is unusual cage and it don't have plus, minus, or multiply. It's given, so we put 4 here. In this cage, we have 2 divided by 2. So, 2 divided by 2 equals 1. And 4 divided by 2 equals 2. The number in this cage when subtracted is equal to 2. So, we fill this cage, we need a 3. Let's move to 16. We need to get the factor of 16, so the only factor of 16 was 4 times 4 times 1 or 4 times 2 times 2 work in this cage. Only 4 times 2 times 2 can work here because we already have 4 in row 2 in the rightmost square. So, we are going to put 2 here, 4 in here, and 2 in here. So, we now fill this cage. 3 plus 3 plus 1 is equal to 7 plus, or positive. We already have 2, 4, and 3 in here. So, we are going to put 1 in here. And the other cage, we are going to put 3 in here so that it equals to 7. So, how about the factor of 12? In this cage, we only about 3 times 2 times 2 or 3 times 4 times 1. Only 3 times 2 times 2 times 1 can work here. So we are going to put 1 here and 4 in here and 3 in here. We already solved this one, so we are going to put 2 and 1 in here and 4 and 2 in this cage. So let's move here. We cannot put 2, 3, 4 here because it's in the row, so let's put 1 and 3 in here. So that's how to solve can-can puzzle. Each cage in a can-can contains a target number. In most contain an operator. If you see a single cell cage with just a number and no operator, it means that the value in the cell is the target number. Such single cell cages work like givens in Sudoku puzzles. You won't see this in every puzzle, but when you do choose 1, you should start there. In the puzzle, we can immediately place a 4 in the upper right cell.